What is the ratio of the area of a circle and an equilateral triangle whose diameter and the side are respectively equal? So here we're talking about a circle, and we know area of circle is given as pi r square. And then we have also an equilateral triangle. And area of an equilateral triangle is given as root 3 by 4 side square. The diameter and the side are equal, which means the diameter is equal to the side. Diameter is 2r, so 2r is equal to s. We have to find the ratio of area of circle over area of the triangle. Now area of the circle is pi r square divided by area of the triangle root 3 by 4 side square. So we'll solve this. Pi r square, the division will make multiplication, so we take reciprocal here, side square. So we have pi r square into 4. Now we know the side here is 2r, so we put 2r the whole square. And when we solve this now, we will get pi r square into 4 over root 3 4r square. So 4 cancels, r square cancels, and what remains behind is pi over root 3. So this is the answer, pi ratio root 3. If the circumferences of two circles are in a ratio 2:3, which means circumference A1, which is 2 pi r1, and circumference 2 is 2 pi r2, and the ratio is 2:3. So we can say 2 pi r1 over 2 pi r2 equal to 2 over 3. Here 2 pi would cancel out, and now we would get r1 over r2 is 2 by 3. We need to find the ratio of their areas. Now for ratio of the areas is A1 over A2 of a circle is pi r1 square over pi r2 square. Pi would cancel out, and you'll have r1 over r2 the whole square. Now we know r1 over r2 here is 2 by 3. We found it here, r1 by r2, 2 by 3. So this is 2 by 3 the whole square. So A1 over A2 equal to 4 by 9. So the answer is 4:9. Write the area of a sector whose radius is r and length of the arc is L. So here we know area of sector. The formula we give as theta by 360 pi r square. But there's another formula for area of sector. Area of sector is also equal to half r into L, where L is the radius and L is the length of the arc. What is the length in the terms of pi of an arc that subtends 36 degrees? So theta equal to 36 degrees at the center of the circle and radius 5 centimeters. So radius r is 5 centimeter. We need to know length of the arc. So the formula for length of the arc is theta over 360 2 pi r. Here theta is 36. Here theta we have 36. 360 2 pi r is 5. Now when I cancel this, my answer comes as 5 centimeter. We have to do it in the terms of pi, so we don't substitute for pi. What is the angle subtended at the center, which means we need to find theta. of a circle of radius 6, arc of length 3 pi. So length of the arc is 3 pi centimeter. So we first write the formula. Length of arc equal to theta 360 2 pi r. Now let's put the values that we know. We know the length of the arc here is given as 3 pi. Theta we don't know, so 360 we write 2 pi, and the r is given as 6. So into 6. So we now cancel out. We'll first cancel the pi and pi on either sides, and then we have now 3 equal to theta into 2 into 6 over 360. So this will cancel out into 60. This will again cancel out and become 30. So theta will be 30 into 3, and that is 90 equal to theta. So the angle theta equal to 90 degrees. What is the area of the sector? So here we need to find area of sector. So that is question mark. Radius 5 centimeters. So r 5 centimeters. Length of the arc 3.5. Length equal to 3.5 centimeter. So let's write the formula. We know area of sector equal to half into radius into length of the arc. Now we put the values. This is half. R we know is 5 and L we know is 3.5. If you work this, your answer is 8.75 centimeter square. In a circle of radius 10 centimeter, so we have radius 10 centimeter and arc subtends 108 degrees. So theta 108 degrees at the center. What is the area of the sector in the terms of pi? So area of sector we know is theta 360 pi r square. Now theta is given here as 108. So this is 108 over 360. We keep pi as it is because if we have to do it in the terms of pi, radius is 10. So this is 10 square. So 108 over 360 into pi into 10 into 10. You cancel this and your answer, reduce it, and your answer will come 30 pi centimeter. If a square is inscribed in a circle, so here we have a square A, B, C, D, which is inscribed in a circle. Now we know for square, the area for square is S square, side into side. And so this is our S and here is our S. And for the circle, area of circle is pi r square. Now if we take up the triangle ABC, we see it is a right triangle. Here this is 90. We can use Pythagoras theorem, which means S square plus S square equal to here AC square. So we have 2S square equal to AC square, and AC will be under root 2S square. That is S under root 2. Now AC is the diameter. So our diameter is S under root 2 and your diameter is 2 radius. So 2 radius is S under root 2, which means S now is 2R over under root 2. This is important. We are going to use this now in our ratio. Now we need to find the ratio of the areas of the circle to the square. So circle pi r square divide by square S square. So that is pi r square divide by S square. So we have pi r square divided by, we know the value of s is here, this is the value of s, so we'll put that up, 2r over under root 2 the whole square. So this is where we had stopped to the last slide. So we have pi r square divide, this will become 4r square, root 2 into root 2 is 2. So we have pi r square, the division becomes multiplication, 2 over 4 pi r square. Now we cancel, reduce this, r square, and this is 2. So the answer would now be pi over 2. So the ratio is pi is to 2. Write the formula for the area of the sector of angle theta and circle of radius r. So this is the formula that we use, area of sector equal to theta over 360 pi r square. Write the formula of the area of a segment of a circle of radius r given that the sector angle is theta. Now for the segment, we know this is the center of the circle. Here this would be the segment. Here what we've drawn is a sector, and this would be the segment. This yellow would be the segment. We have to find the area of the segment. This is a segment. So if you see, the area of the segment will be area of the entire sector minus the area of the segment. So minus area of the triangle. So area of segment is equal to area of sector minus area of the triangle. Now area of sector we know is theta 360 pi r square, and of the triangle is sine of theta by 2 cos of theta by 2 r square. So this would be the formula for area of the segment, area of the sector minus area of the triangle. If the adjoining figure is a sector of a circle of radius 10.5 centimeter, so here radius we see r is 10.5 centimeter. What is its perimeter? Now in this sector, if you see, the perimeter is made up of AB, and to find AB, this is the length of the arc, and formula you know is theta 360 into 2 pi r. Theta is 60, 360, 2 pi is 22 by 7, your r is 10.5. So this is the length of the arc, and if you calculate this, the answer comes 11 centimeter. But we are not done. We have this radius plus this radius, and we know each of this radii is given as 10.5 and 10.5, and the length of the arc is 11. So the perimeter of the sector equal to radius plus length of the arc. Radius is 10.5, here 10.5, 10.5 plus length of the arc. Length of the arc we found is 11. So the answer is 32 centimeter. If the diameter of a semicircular protector is 14 centimeters, so we have diameter equal to 14 centimeter, radius would be half of it, that would be 7 centimeter. Find the perimeter. Now here is the protector, and protector has got two parts. It has got this part which is equal to the diameter, and that would be 14 centimeter. And then we have the circular part, and here is a circular part. This is the circular part of the protector. It's a semicircle, and hence the length of this will be 2 pi r divided by 2, which is pi r. Pi is 22 by 7 and the r we know is 7. So this is 22. So when we are finding the perimeter of the protector, it is made up of two parts. One is 14 centimeters, which is the diameter, and so we just write it straight on, 14 plus 22, and that would be 36 centimeter. So we add up 14 and 22. Let's just repeat that again. So this is 14, we have this which is 14, and then we had this which is 22. It has got two parts. An arc subtends an angle of 90 degrees at the center, which means theta equal to 90 degrees of a circle of radius 14. So radius 14 centimeter. Write the area of the minor sector. So area of sector, formula theta 360 pi r square. Theta we know is 90. This is 360. We write pi because we have to do it in the terms of pi, so we must not substitute for pi. And the r is 14, so 14 into 14. And when you work this up, you get the answer 49 pi centimeter square. Find the area of the largest triangle that can be inscribed in a semicircle of radius r. So this is a semicircle. Now we have to inscribe a triangle in it. We have to draw a triangle in it. So here is the base of the triangle, and this would be the triangle that you can draw in it. Now for this we know the base. This is the base of the triangle, which is 2r because it is a diameter. And here we'll have the height. This is 90 degrees. And you know the height of the triangle will be the radius. So this height will be now r. So the area of this triangle, this is the triangle, the area will be half base into height. So the base we know is 2r and the height is r. This is r. So area equal to half base into height, that is half 2r into r, and r square unit square. So this is a triangle inscribed in a semicircle. Find the area of a sector of a circle of radius 21. So we have radius 21 centimeter, central angle 120. So theta 120 degrees. And formula for area of sector we know is theta 360 pi r square. Theta 120, 360 pi 22 by 7, r is 21, so 21 into 21 because it is r square. You work this out, you get 462 centimeter square. What is the area of a square inscribed in a circle of diameter p centimeters? So here we have a circle. This is the diameter of the circle. Let's draw the, and this is given as p. First we have to draw the right triangle. This is the right triangle. So in this right triangle here are the sides of the triangle. This is 90 degrees, so we'll mark it as A, B, C and D. So in triangle ABC, Pythagoras theorem, so we see that S square plus S square equal to P square. That is Pythagoras theorem. So we have S square side square equal to P square. So 2S square equal to P square. So S square equal to P square over 2. Now what is S square? We see here in the square, the side is S. Therefore, the area will be S square. So remember, S square is the area of the square. So here this S square is the area of the square. So area of square equal to P square over 2. So this is the answer, p square over 2. Is it true that the area of the segment of a circle is less than the corresponding sector? Let us see what is segment and what is sector. First I'm going to draw the sector. So this is the center. This is the sector of the circle. So here is the sector of the circle. Now let me denote what is the segment of the circle. The segment of the circle is a chord with the arc. So this is the segment of the circle. And you will definitely agree that the segment is less than the sector. So here we have the sector and this is the segment. Definitely sector is greater than a segment, because if you want to complete this, this would be the sector, this entire thing. So we know that sector is greater than the segment. So the above statement is false. Here they say the segment is less. Is it true to say that area of segment of a circle is less than the area of the corresponding sector? Now this is true. This would be, yes, segment is less than the sector, but this only holds good for minor segment and minor sector. But what happens in the major sector and segment? Now this is the major segment, more than semicircle. This is major segment, and now this would be the major sector, more than the semicircle. So here is major segment and this is major sector. And in this case you will see that segment is greater than the sector. So that earlier statement is true only for minor, not for major. In the major you will find segment is greater than sector for major. Major is more than semicircle. If the numerical value of area of the circle is equal to the circumference, so here they say area of circle numerically equal to the circumference. So what is area of the circle? Pi r square. Circumference 2 pi r. I'll cancel r on the other side and pi also, and you get r equal to 2 units. So for r equal to 2 units, the area of the circle is numerically equal to the circumference. Here pi we cancel, this r and this r, and you get r equal to 2. How many revolutions a circular wheel of radius r meter makes in covering a distance of s meters? Now for a wheel, we know, in the case of a wheel, for one revolution it covers one circumference. The distance covered is one circumference. So this is the distance. So if you have now, in this case you have for r radius, so circumference means for one revolution it would cover a distance of one circumference, means 2 pi r. So if you have n revolutions, it will cover a distance of n into 2 pi r. So we can have the formula distance covered equal to n, number of revolution, into circumference. This is circumference, this is number of revolutions. So distance is circumference into number of revolutions. Now in this case the distance is given as s, so we have n 2 pi r, and we need to find n. So n will be equal to s over 2 pi r. Find the ratio of the area of the circle circumscribing a square to the area of a circle inscribed in a square. So here first we have this circle, this is inscribed circle, this is a circle inside the square. And we know area of this is inscribed circle inside the square is pi r square. the r here in this case, here is your side S, and we see that the side equal to the diameter. That means S equal to 2r, and your r is S by 2. So the area of incircle equal to pi r square, pi and the r is S by 2. So here I put S by 2 the whole square. So this is now S square by 4 pi. That is area of incircle. Now let me see of circumcircle. Now this is a circumcircle. So for circumcircle is outside the square, we see that the diameter, this is the diameter here, equal to diagonal. The diameter of the circle equal to diagonal of the square. Diameter now we know says 2r, and to find the diagonal we know this is S and S, and say the diameter is now x. So we'll have S square plus S square equal to x square. So 2s square equal to x square, and your x will be under root 2s square. So s under root 2 equal to x. That is your diameter, or that's the diagonal. So your diagonal is s under root 2. So your r now is s under root 2 over 2r over 2. So for the circumcircle, the outer circle, we saw the radius is s under root over 2. Now area we know is pi r square, which means pi, the r is s under root 2 over 2 the whole square. So that is pi into s square into 2 over 4. So this area is now, I cancel it, so it will be pi s square over 2. And for incircle, we already have found of incircle, the area is pi s square over 4. Now to find the ratio of circle over incircle. So circumcircle is pi s square over 2 divided by incircle, pi s square over 4. So pi s square over 2 multiplied by 4 over pi s square. You cancel this, you get 2 is to 1. So ratio is 2 is to 1. Circumcircle over incircle.